Hi, everyone. Thanks for attending today. My name is Gerry Miller. I'm the founder and CEO of Cloudticity. Today, we're going to talk about data in healthcare and ways that we've approached that using cloud-native data interoperability solutions. We're going to quickly give a little bit of background on Cloudticity, who we are, where we came from. We're going to talk a little bit about the why before we talk about the what. So we're going to talk about what's driving the proliferation of data in healthcare. We're going to talk about how the cloud has driven a tremendous amount of innovation and ability to leverage those data and center that around an AWS native solution that we developed at Cloudticity, the Healthcare Data Hub. And finally, I'll present a case study and talk about a real-life example of where this technology was tremendously effective in helping the state of New York combat the COVID-19 challenge. We started Cloudticity in 2011, so we've been around for almost a decade. With the singular mission of helping healthcare organizations be successful on the cloud. We've got a number of competencies and certifications, including HITRUST, as well as the AWS Advanced Consulting Partner designation. This is because we focused exclusively on healthcare really from day one. So healthcare is interesting. There were some seminal events this decade that really drove the proliferation of healthcare data. The HITECH Act drove digitization in the US of healthcare records and really drove the adoption of electronic health record systems across the world. Also in the US, there were significant changes, as many of you know, in the US, we don't have a single payer health system. And so, people are responsible to get their own health insurance. And there's a proliferation of the ways that insurance companies were dealing with their patients. The Affordable Care Act, otherwise known as Obamacare, really changed that tremendously and required health payers to leverage data to really change the way that they worked with the members of their payer networks. We also saw the proliferation of medical technology devices, Fitbits, implantables, wearables, swallowables. The US Federal Food and Drug Administration started approving things like the first subdermal continuous glucose monitor that transmits a continuous data stream over Bluetooth. So we see a tremendous drive toward building and delivering a gigantic amount of healthcare data. In addition, genomic sequencing has become affordable by factors of thousands or millions, and so we're starting also to see not only a proliferation of personal telemetry data, health electronic data, but also genomic data that is being merged with the clinical data for precision health decisions. The challenge with so much data is multifold. First of all, it comes in a variety of data formats. So in the healthcare industry, we've got HL7, V2, CCDAs. We get JSON, XML, proprietary formats like DICOM, CSVs. The data come from many different environments, in many cases locked away in proprietary systems. And they also use different coding systems, whether it's ICD-9 or ICD-10 or LOINC or SNOMED. So building value and use out of such disparate data formats and coding styles can be challenging. On top of that, we've got additional problems around things like patient matching. My name is Gerry. Some people spell it with a G, some with a J. My mom calls me Gerald. If different health systems annotate my name differently, how do we track my journey through the health system and know that I'm the same person, even though I might be annotated differently each time? So patient matching is a challenge. The traditional approach in healthcare has been to use integration engines, which in the 1990s worked really well with data centers and that sort of thing. But today, the licensing for these integrations tends to be very expensive. They were designed for a 1990s data center, so they don't scale very well. And they tend to store their data in proprietary formats. So you can't access the information using modern open source tools. Those are some of the challenges that traditional systems and traditional mechanisms bring up when we're trying to integrate all of these disparate data formats and types. But if you think about the opportunities that we have to deeply view into a patient's condition in real time by organizing all of the information so that we can see this holistic longitudinal view of the person, not just the patient and not just the current crisis that they might be facing. The opportunities for better clinical care and lower costs are tremendous. So we approached that with a cloud native solution. What some of the things that we really like about the cloud? Number one, it provides us the opportunity to access almost limitless storage. So we can build these massive data lakes that operate and consume tremendous amounts of data at unthinkably low prices if you compare it to traditional solutions. The cloud also offers a tremendous amount of scalability. We can throw as much or as little compute power as we need at the problem, which gives us a tremendous amount of flexibility in how we leverage these disparate health data sets. A third thing is that working with the cloud, we can automate everything. And so things that used to be manual processes now take place with automation. We try to remove as much opportunity for human error and human cost from the equation and leverage code to do things that used to take armies of people. And finally, because we have such deep, rich, large data sets and the ability to rapidly spin up and spin down computing power, we can leverage advanced technologies like machine learning to do things like uncover hidden correlations and drive much, much better clinical outcomes and much better utilization across our health systems. So the Cloudticity Healthcare Data Hub is the product that we built at Cloudticity, powered by AWS, that allows us to deploy and scale a fully functional healthcare integration environment, including a data lake, in about 15 minutes. We automate everything from data ingestion to transformation. We scale tremendously, although it follows the AWS precept of pay only for what you use. And so with inherently no bandwidth limitations, no data limitations, we can scale up and down not only capability and capacity, but cost as needed. One of the key tenets that we worked on with the Healthcare Data Hub is that we decouple data ingestion, data storage, and data use. And so data are stored in an open source format. We use Hadoop in a binary Apache Parquet data store. We don't apply schema until the data are queried, which means we can have disparate data sources that we don't have to operate all these ETL processes on, but instead can store them in the raw native format, but derive meaningful business and clinical value upon query. The data store is a single consolidated data store, so we have a data lake, so we don't have to work on all of these disparate systems. And the most important thing is the Healthcare Data Hub is 100% cloud native. There's not a single server, not a single virtual server involved. End to end, we use AWS native cloud services to build a highly, highly functional integration environment without the traditional costs and hardware requirements. We put this to the test on March 23rd when we received the call from the state of New York in the US asking us if we could provide some technology underpinnings to help them address the critical problem that they were experiencing with COVID-19. On March 23rd, New York was the worst state in the country. It was impacted worse than any other state, had more COVID cases per capita, more COVID deaths per capita than any other place in the US. We had an operational data lake up and running, flowing data from every provider in the state of New York related to COVID patients in 6 days. And in 6 weeks, New York State went from being the hardest hit state in the country to the first state that crossed green with a reduction in COVID cases. We drove things like the ability to analyze comorbidities, the ability to identify demographic populations that might be most hard hit. We drove things like the ability to predict inventory of ventilators or ICU beds, and drove the contact tracing program that allowed New York to track COVID positive patients, identify who they may have been in contact with, and break the cycle of increasing infections. We really enjoyed building the Healthcare Data Hub on the cloud because it allowed us to start with a blank sheet of paper. We didn't have to say, how has this problem been traditionally approached and how can we incrementally iterate on that? Instead, we were able to say, how can we revolutionize the way that healthcare data interoperability works by not relying on anything that's been done in the past, but asking ourselves, if we were to start addressing this problem today, how would we do it? We were able to iterate rapidly. So as new requirements came up, the ability to handle proprietary data formats or add support for FHIR, XML support for CCDA, we were able to generate those new features in hours or days rather than months or years. Because it's a 100% cloud native serverless architecture, the costs are low, the maintenance requirements are low, and the scalability is tremendously high. We allow data access by any open source tools that can query Hadoop. So we use Amazon Athena, which is a managed Presto service, Amazon SageMaker, which drives machine learning models. The data are not in any proprietary format, so you can use open source tools like Spark or R, external tools like Tableau or Amazon QuickSight for visualization in a way that is highly effective, highly scalable, and highly cost efficient. If you're interested in learning more, please visit us at cloudticity.com/data demo, where I deliver a video demonstration of the capabilities of the Healthcare Data Hub. And please reach out to us if you'd like to learn more. Thank you very much for your time today.